So I posted this after class on Tuesday, but on that Canvas discussion, there's a handful of people, and it didn't have it in the prompt. I know I mentioned in class, I think it had it in the slides when I talked about the Canvas discussions, but every Canvas discussion, you should have your initial post, but also 2 responses to other students. So there's a significant number of people that I think missed that because it wasn't in the prompt, but it's for every single Canvas discussion, you'll have your initial post and then 2 replies to other students. So I reopened it, and if you already had made a post and you now then post your 2 replies, I'll accept those by the end of the day today. So hopefully you either already got that done, or kind of get that done by the end of the day, okay? So if you only posted 1 initial response, you should have also posted 2 replies to other students. After tonight, my GAs will start working through those, kind of getting those graded. Those should be graded by next Tuesday's class, which we will just be doing review. And I'll kind of put up a new module after today's class on Canvas that says like exam 1 or midterm exam 1, where it'll have this practice exam, also has the answer key. That's what we'll be doing in next Tuesday's class, is just doing review. So once we get to next Tuesday's class, after class today, I'll also publish that 4th module quiz. That'll be due at the end of the day, Monday. So you can ask questions from that practice exam. You can ask questions from any of the old quizzes, ask questions from the old practice exams. That's what we'll be doing in Tuesday's class, okay? So, I mean, I'm giving it to you because I think that it's worth working through. So if I've been asked, if I'm prioritizing the number one thing, if I'm rank ordering, I'd go through that practice exam, then I'd go through the old quiz questions, then I'd go through old practice problems. Then if I still want to go through things, old in-class questions, top hat questions. I'll also likely tomorrow get up another set of questions. That it won't be like a full practice exam, but it'll probably be at least 15 questions, a few more from like module 1, because that one I have up there now is really kind of starts at module 2. So there won't be, we'll talk more about the logistics of the exam on Tuesday, but there won't be as many questions from module 1. I mean, even the module 1 quiz, right, was half syllabus stuff. You're not going to have syllabus questions on the exam. So I'll get up another small set of questions, but for right now, that practice exam would be kind of the main thing I kind of focus on. It's pretty similar to what you'll see on the exam, okay? All right. Other than that, any other questions for me before we kind of dive into where we left off in module 4 material? Okay, so CL sessions tonight and Monday, we'll be going over module 4. After class next Tuesday, I'll try to get up the kind of current CL attendance just to make sure, kind of verify that if you think you've been to a certain number, I'll kind of have that up on Canvas to kind of show you I have them recording this off of Canvas. We'll kind of upload them, usually not every single week, but kind of at like the midterm exam points. And then towards the end of the semester, I'll start uploading them every single week, so we can kind of make sure that what you believe should be your number of attendance is exactly what's been recorded, okay? All right, all the housekeeping stuff out of the way. We talked about these at the end of last class, so I'll go through these a little bit quick to kind of save us some time for stuff that's a little bit more difficult today. But we talked about what are some of the things that are going to influence whether or not a product is elastic or inelastic, right? So remember, elastic was that it's very responsive to price changes. So we said, if there's a lot of substitutes, right? So if I go to the store and I want to buy a box of cereal, there are a lot of substitutes. If one of those boxes is $2 higher than the rest, what do you think most people are going to do? Not buy that one, buy the others, right? Or if General Mills starts to increase the price of their product, what do people start to do? Well, maybe, I don't know, I like their brand a little better. I start buying other brands that are basically the same product, just not name brand, right? And so when you have more substitutes, people are going to be more responsive to price changes, or we would say they're going to be more elastic, right? If you think about things for like, there's not a lot of substitutes. So like Super Bowl tickets, there's one Super Bowl. What do you think they can do? Charge a really high price. And how many tickets do you think they still sell? All of them, right? Super Bowl tickets, I mean, it's probably not truly perfectly inelastic. I'm sure if they charged $50,000, they might not sell it out. But, you know, the current prices that they're looking at, it's very, very inelastic. People aren't very responsive to price changes when there aren't many other substitutes, right? So another good example, like most counties, cities, there's one electric company. If I want to use electricity, I can't, you know, I'm not going to be that. I've got to, you know, run my air conditioner or whatever. I'm probably going to use about the same amount, regardless of what price that they're able to charge. Okay. I'll skip this for a second because we said last class, what is closely related to this idea of substitutes? If I have more time to make a decision, what can I find more of? Substitutes. If I have more substitutes, we said demand is going to be more elastic or more responsive to price changes. So think about this like in terms of like an airline. If I need to take a trip 6 months from now, what can I do? Over the next couple months, continuously like check to see what's happening to prices, you know, flights to this location. I can be a lot more picky about what price I end up paying. I'm a lot more sensitive to changes in that price. If I don't have a lot of time, I can't find as many substitutes. If I have to be somewhere next week and I'm looking for an airline ticket, what could they do? Increase the price by quite a bit, and I'm kind of stuck, right? So anytime you have more time, you can be more elastic, you can find more substitutes. Less time, less elastic, you're also going to be able to find less substitutes. So those two things are kind of closely related. Now, if we think about proportions of our income, right? If I'm spending a lot of my income on something, do you think I'm going to pay more or less attention to the price? If I'm spending half of my income on, say, like a house or my rental amount every month, I'm going to try to find a really good deal, right? This is why people haggle with car salesmen over hundreds of dollars for a $50,000 brand new car, right? And I think the example I used last class was like a pack of gum or, you know, in light of recent events, my wife's trying to kick me of this habit, but I was like, I'm terribly addicted to Diet Mountain Dew. If I go to a gas station and I found, you know, 44 ounces, 90 cents or $1.30, guess how many I buy? The same one, right? You know, if it's a very small proportion of my income, I don't really react to that pretty sizable percentage change in price. I keep buying about the same amount. I'm pretty inelastic, right? So spending more of your income, you're going to be more elastic, less of your income, less elastic. So when we look at goods, I had someone ask me, I don't know if they were from this section or the other one the other day, about like financial versus economic consulting and kind of not going too far down that path. You know, economics kind of gives us a way of analyzing things, and it is data driven, but it also gives us the tools to be able to analyze situations that we may not have data on, right? So these are like kind of the intuitive descriptions of what we know. Now we can go out and gather data and back this up, but I think this should hopefully be, you know, intuitively make sense here, right? So if I actually looked at some goods, I can kind of prove some of these attributes. So like books of matches or like boxes of matches that are very small proportion of someone's income, but also like, I don't know, there's really only one other substitute, which would be a lighter, right? So few substitutes. I probably have lots of time to, maybe if I need, if I want to smoke, I might need them right away. So I don't have a lot of time. I need something right away. They're a small proportion of my income. People are very inelastic, right? Airline tickets are another good example because if I look at airline tickets in the short run, and I forget, I pulled this from an economic database, I think their definition was like under 2 weeks. Under 2 weeks, if you need an airline ticket, their measure of the price elasticity of demand, very inelastic. They have less time, they should be less elastic or more inelastic, right? Less than 1. And then if you have more time to find those airline tickets, they found elasticity of demand was actually above 1. It's actually elastic product if people have more time. So same product, but an attribute changes about it can switch it from being what? An elasticity above 1, making it elastic, to an elasticity less than 1, making it an inelastic product, right? And if I'm selling this, what do I like? If I want to increase the price, what do I hope consumers are? Inelastic, right? Because then I still sell about the same amount, but I can sell it for an even higher value, okay? Just some other, I know there's some other examples here. The other one, I think is a good, like coffee and tobacco. I just think this one's interesting. Both of these are probably relatively about the same proportion of someone's income. But what are they? If I'm like addicted to caffeine or tobacco, there are not many substitutes for that, right? Or I might need them now, so I have less time. So both of them are inelastic. I always find it interesting that coffee is even more inelastic than tobacco products, which may tell you something about how addictive it is. But we could look at a bunch of different goods. I think I have this one up here. I won't spend a lot of time with this, but I found this and thought it was interesting. Like even in the same category of goods, so I have like a bunch of different alcoholic drinks, like the category out on its whole, fairly inelastic. Looks like it's about 0.45. And these are negative. We've been just looking at the absolute value in this class. But if you break this down in different categories, beer tends to be a little bit more elastic. Tequila, I always tell my wife like it all tastes the same. She thinks it doesn't. But here it looks like consumers think the same thing, because if they're pretty elastic, that must mean that for tequila, there's a lot of substitutes. Like they don't mind substituting towards other things or other brands of tequila. And then you can kind of break this down by other categories. So I always thought this is kind of interesting. Like even in the same category of products, we have elasticities that are like really close to 0 and as high as almost 2, right? So these are just kind of those 3 attributes will be the ones that we focus on: more substitutes, more time, and then a greater or less proportion of your income. Okay. So we ended last class with a question like that in the in-class quiz. I also started talking about this in a way that's not quite accurate, but it like set us up to be able to think about it. So I said when we had perfectly inelastic demand, that meant what? That as I changed the price, the amount people bought stayed the same. So we had what? A completely vertical demand curve, right? Quantity was on our x-axis, so quantity stayed the same. A vertical demand curve has a slope of what? So if it's horizontal, my slope is 0. If it's vertical, my slope is infinite. But my elasticity measure for a vertical curve, we said it was perfectly inelastic, so my elasticity would be 0. They're completely the opposite, right? My slope and my elasticity are related, but they're like inversely related. And here's where they're not quite an inverse relationship. In saying that, it helps get this idea, but it's not quite accurate, because we actually have the same demand curve, even if it's linear. And all we're going to work with in this class are linear demand curves. If you go to the next level of microeconomics, you start to look at demand curves that have some curvature to them, or a second derivative that's not 0. And so if I've got a linear demand curve, it's the same slope. No matter what 2 points I use, the slope is the same. But what won't be true is the elasticity is different at different points of that demand curve. So same slope, but depending on where we're at on that curve, different measures of the elasticity. So in general, as we move down the demand curve, it's going to become more inelastic. So I've got some numbers that'll kind of prove this to us. I think I might have done something similar to this last class, but I think it's worthwhile to kind of go through it and set it up again like this, okay? So let's say I've got this nice linear demand curve, okay? Initially, sorry, this is price. Initially, when prices are high, right? And I'm thinking about my elasticity is my percent change in the quantity demanded for good X over the percentage change in the price of that good, okay? So here, when prices are high, I'm going to be up here on the upper part of my demand curve. So even a change in the price of 1, that's going to be a relatively small what? Percentage change in my price. So I'm going to have a relatively small percentage change in price, but going from 1 to 2, the change in my quantity, the percentage change is going to be relatively large, right, or high. So if I take a relatively large percent change over a small percent change, this fraction is going to be greater than 1, or we would say that this portion of the demand curve is elastic. Now, when I'm looking at the lower part, right, of this demand curve, now it's kind of like the opposite. Now, I'm thinking about my elasticity of demand, the percentage change in price going from 2 to 1, that's going to be a relatively large percentage change in price. Whereas going from 99 to 100, I'm dealing with higher quantities. Now I'm going to have relatively small percentage changes. Right? So if I've got a small number over a larger number, this is going to be less than 1. So down here on the bottom part of our demand curve, we're actually going to have elasticities that tell us that the demand is inelastic. Okay. Now, I drew it kind of large, and later on in the class, we'll see it's not really in practice quite this large. But as I move down this curve, the same principle applies. I use the extremes here, but it starts out elastic. That price elasticity of demand is getting smaller and smaller and smaller until it becomes inelastic. Well, if it goes from being inelastic at some point, what is it going to be? Equal to 1, which is, we said, unit elastic. So the same demand curve will have a portion that is unit elastic in the middle. At prices above that, we're going to have elasticities that are higher than 1 or elastic demand. For prices that put us on the demand curve below that, that's going to give us elasticities less than 1 or on the inelastic portion. Okay? Any questions on this idea? Okay. Yeah. I mean, you can, yeah, so I'll put some numbers to it. I just chose these, like, if you think about a percentage change, I mean, if I calculate the percent change here, how do we find a percentage change? We said last class using the midpoint method, you take the change and you divide it by the average, right? So the change is 1, the average is 1.5, right? So this would be like a what, 67% change in price. But with quantities, I can't even do, I mean, this is going to be what, 1 over 99.5? I mean, this is almost like a 1% change in the quantity demanded. So I'm just talking about this in generalities, like, you know, if we don't use the midpoint method, like this is getting cut in half. This is only going up by like 1%, you know, I'm just kind of roughly talking about percentages. If you want some actual numbers, let's say I had a demand curve that looked like this. And I'm not going to sit here and spend a ton of time calculating these values for you. We did a lot of that last class using that midpoint method. But if I wanted to move from the price of 30 to 20 here, so I'm on the higher part of my demand curve. So I already know that this portion of my demand curve should be what? So it's going to start out elastic, become unit. It's getting lower, so it then becomes unit elastic, then becomes inelastic. If I calculate my elasticity of demand, that's my percentage change in the quantity demanded. So how am I coming up with this? Well, quantity between these 2 points is going from 0 to 20. So we said using the midpoint method, I find the percentage change by looking at the actual change and dividing it by the average. So it changes by 20. What's the average of 20 and 0? 10. 20 over 10 would be 2. We said when we're calculating these behind, like, I'm showing them to you as a percent. 2 is basically 200% just in decimal form. So if you were to calculate these yourself using the midpoint method, the intermediate values you come up with won't be in terms of percentages. They'll basically be in terms of proportions, but we can go back and forth between proportions and percentages by simply multiplying by 100. They tell us the same thing. Okay? So 20 over the average of 10 gives us that percent change in the quantity demanded of 200%. If I look at the percent change in price, well, what's my change in price? 30 to 20 is? Jesus. 30 to 20 is 10. The average of 30 and 20 would be 25. Guys, we got to be able to take the average of two numbers that are that easy, right? So 10 over 25, that's going to end up being 0.4, or as a percentage, 40%. I plug those into my elasticity of demand. I've got an elasticity of 5. Sure enough, it's elastic. Okay? I then could do the same thing, but if I'm moving from 20 to 10, using that midpoint method, calculate my percentage change in the quantity demanded, percentage change in price. Here, I end up finding they're the exact same value. So if I take what? The change in the price of 10 divided by the average price of 15, That's what, 0.67 or 67%. If I take the change in the quantity of 20 divided by the average of 30, that's 0.67 or 67%. So in that middle part of my demand curve, I have the exact same percent changes in both of these things, so my product is unit elastic. If I then continue, I know that I keep moving down the demand curve, it's becoming more and more inelastic. Down here, my elasticity measure should be less than 1. Sure enough, if I use those values to compute that, I'll find that, sure enough, it's less than 1, ends up being what, 0.2 in this example, right? So this is just putting numbers to it to prove to you what I was saying over here wasn't like a bunch of BS, right? Like we can actually calculate, we could go through the mathematical proof, but it's kind of outside the scope of this class. But as we move down any linear curve, this ratio of that percentage change in my X to the Y, quantity to price, will be getting lower and lower. If it's getting lower and lower, closer to 0, it's becoming more and more inelastic, okay? But you could prove this to yourself using any demand curve, okay? Any questions on anything there before we keep moving? Okay, so I've got an email or two, and just to be clear, we're talking about percentage changes for this module, and really in this class, we don't use it a lot of other places. In practice, if you're looking at these things, usually you have like a base that you're saying like, what was the percent change from the initial base number? Because we aren't really looking at a base number, we're looking at the elasticity of a portion of the demand curve. The base isn't 30 or 20, right? We're looking at the elasticity of this segment of the demand curve, which is why we're using that midpoint method. So the way that we're going to calculate percentage changes for our supply, our demand curves, anything graphically we're looking at, we're going to look at the percentage change using the midpoint method will be the actual change divided by the average of those two numbers, okay? Any other questions on that? We're okay with this? Sure. Okay. So the next thing we'll kind of talk about is why do we care that the elasticity changes along this demand curve? Well, it's going to tell us something about revenues, okay? So I'm going to jump the gun a little bit in terms of the slides. We might be a little bit out of order, but we'll kind of hit things when we get there. So we've got, I've got my marker bleeding through is what I've got. So let's say I'm looking at a demand curve, okay? And how are we going to find the total revenue that a company makes? It's simply going to be the price they sell a good for times the quantity they sell. That's total revenue. It's how many units I'm selling times how much am I selling each unit for. Now, we said that initially, my demand curve is going to start out as elastic, okay? That means it's going to have an elasticity greater than 1, right? And that's going to mean that my elastic demand, so this is the percentage change in the quantity demanded over my percentage change in price. If I rearrange this a little bit, right? If I know that this is greater than 1, if I multiply both sides, if this fraction is greater than 1, what has to be true? My percentage change in the quantity demanded has to be greater than that percentage change in price. So we're going to use that here in a second, okay? So what we're going to want to do is stack these graphs where I'm looking at quantity still on my x-axis, but I'm now looking on my y-axis, what is the total revenue from selling this many units based off of the price I can charge, given what my current demand is, okay? So here, if I think about, I probably should have saved space over here, but when I've got elastic demand, we said that means that percentage change in the quantity demanded is greater than my percentage change in price, right? So if I think about total revenue being price times quantity, if I set this price, how many units am I selling? 0. So my total revenue would be anything times 0 is 0. If I lower the price a little bit, right? what's going to happen? Well, if I decrease the price, I know that the percentage change in the price when I'm on the elastic portion, what will be the corresponding, so quantities going up, right? I know that the change in quantity is going to be even larger, or at least in terms of the percentages, right? So when I think about that percentage change in quantity demand, it's going to more than compensate for the fact that I'm lowering the price. So what's going to happen to my total revenues? Which of the, I try to draw the arrows to scale, which of these is going to win out? The larger change. So as I lower the price, I'm selling more units. My total revenues are going up, right? People are very elastic. So when I just decrease the price by a little bit, yeah, that hurts my total revenues because I'm not selling it for as much, but people are buying way more units, right? So when demand is elastic, lowering the price actually increases our total revenues, right? Now, if I was over here on the inelastic portion of my demand curve, right? Well, if I had inelastic, or if I was on the inelastic portion, what has to be true? Well, if this percent change in my quantity demanded over the percentage change in price is less than 1, if I rearrange this a little bit, what would have to be true? That denominator is larger, right? That's the only way that fraction is less than 1. So I know that when I have inelastic demand, that percentage change in price is actually larger than my percentage change in the quantity demanded. That's the only way this fraction is less than 1. Or I could rearrange this equation if that's easier to think about. Okay. So when I'm over here, if this is the price I charge, 0, what's my total revenue? I'm selling a lot of units, but if I'm selling for $0, how much money did I make? Yeah, 0, right? Now, if I increase the price here, so if I think about total revenues, well, here. Now, when I'm increasing the price, right? If it's inelastic, I'm going to have really large percent changes in the price. Now, people are going to buy less, but the amount that they're buying less is going to be smaller than that. So what's going to happen to my total revenues? As I increase the price, sell fewer units, here, my total revenues are actually going up, right? So depending on what portion of the demand curve I'm on, I want to do different things. When I was on the elastic portion, how did I increase total revenues? I lowered the price. When I'm on the inelastic portion, how do I increase total revenues? I actually increase the price. Now, I drew it larger than it probably is in practice, but if I was on the unit elastic portion, what's going to be true? Well, we kind of already looked at the numbers for this, but if my elasticity of demand is 1, what's going to be true about my percent change in the quantity demanded relative to the percentage change in price? If it's equal to 1, they're going to be the same thing. So when I'm thinking about total revenue, whether or not I increase or decrease the price, it's going to be matched with an equal percent change in the opposite direction in quantity. So what's going to happen to my total revenues when I'm on the unit elastic portion of the demand curve? These will equally offset, so total revenues will remain unchanged. So it would be like kind of like this flat kind of point. Okay. Your question? Yeah. Say it again. Yeah, so if I'm on the inelastic portion, why do I want to increase the price? So you can think about moving from the most extreme, but as I increase the price, is that going to be a good or bad thing for total revenues? Good. I'm selling my product for more money. If it's inelastic, I know that increase in price, well, no matter if it's elastic or inelastic, if I increase the price, people are going to buy less, right? So that's going to hurt my total revenues. But if it's inelastic, I know that change in the price me increasing the price is going to be greater than the reduction in the number of units people buy. That has to be true if it's inelastic. That's the only way this fraction would be less than 1. So that's why I know I want to increase the price if I'm on the inelastic portion, because that's going to increase my total revenues. Those increases in prices will offset and, more than offset that reduction in quantity. Whereas when I'm on the elastic portion, think about it that way. If I'm on the elastic portion and I increase the price, so what's going to happen if I increase the price and I'm on the elastic portion? Well, there, I know that the change in price is going to be less than the change in quantity. So if I increase the price, people are going to buy way fewer units. So if I increase the price in the elastic portion, what's going to happen? Total revenue. If I increase the price, I'm actually going to be moving down my total revenue curve. Yep. Okay. Any other questions here? Yeah. Any product, right? Anytime we've got a downward sloping demand curve, right? This relationship between elasticity and total revenue will hold. Right? And we can, we could look at any demand curve and kind of pick any points and prove this to ourselves. Like medical equipment? Oh, if it was like perfectly inelastic? A perfectly inelastic curve would present different challenges to us in terms of total revenue, because there, what is total revenue going to be? If I keep selling the same number, what do I always want to do if it's perfectly inelastic? Increase the price. So yes, this would break down if I had a perfectly inelastic curve, right? But is anything truly perfectly inelastic? Probably not. Even life-saving surgeries, people are like, well, guess I'm just going to live out. Right? If I can't get the money, I'm not going to go rob a bank. So I'm, people all the time forego what you would think of the most inelastic product, right? Any other questions here before I keep moving? Okay. So to be fair, if I wanted maybe a slightly more accurate depiction of this, and we'll use this later on, but I drew the unit elastic portion pretty large, right? It's probably not like that. Really, if I can do like 1 cent increments, technically there's going to be like a really, really, really small portion that is unit elastic. So in general, if you want to know about this relationship, or you're trying to draw a picture out for this relationship between your demand curve and total revenues, that unit elastic point is where total revenues are what? At their highest or maximized. And then we always know that our demand curve is going to start out as elastic. The elasticity kind of decreases as we go up. And it's going to not be like linear. It's going to be kind of like this U shape, right? I had kind of drill a little bit straighter here just because it didn't have as much room. But it's going to be more of this kind of U shape total revenue when we're kind of thinking about that relationship of the demand curve to the corresponding total revenues. Okay. I mean, it's the same thing, just right. I'm drawing it out a little bit more accurate. Okay. So we're going to use that concept, and I'm going to show it to you in a couple different ways. So let's instead say, I'm just going to try to show you this with numbers and then a slightly different visual depiction. So here I've got an example where I've got a very basic linear demand curve, right? And I'm going to calculate my elasticity of demand. So how do I find total revenue? It's simply price times quantity. So for this good, if I charge $5, how many am I selling? 0. So my total revenue is 0, right? If I then lower the price, well, if I lower the price to $4, how was I coming up with these percentage changes? Once again, I'm not going to work through every single one, but all we're doing is using the midpoint method. To find that percent change in quantity, I said, what's the change? 1 divided by the average of 0 and 1, which is 0.5. So 1 over 0.5 is 2. We said when we do the intermediate calculations, they're not going to be in terms of percentages, but in terms of like proportions. So if we convert it to percent, 2 would be 200%. And then what's the change, percentage change in price? Well, the change is 1 divided by the average, 4.5. 1 over 4.5 gives us 0.22 or 22%. So if I go ahead and I calculate these price elasticities of demand and then the corresponding total revenue as well, notice whenever the demand is in absolute value greater than 1, right? So we said price elasticity of demand will always technically be negative because price and quantity move in opposite, quantity and demand move in opposite directions. We just cared about the absolute value. So notice when it's greater than 1 or elastic, as I lower the price, sell more units, I'm moving down the demand curve. What did we say should be happening to total revenues? They should be going up. Sure enough, as I lower the price, when it's elastic, what's happening to my total revenues? Well, price times quantity, my total revenues are going up. When I get to that unit elastic point of the demand curve, what should happen if I change the price? Well, at the unit elastic point, we actually said there would be no change. In theory, this is probably going to be like between 2 cents because I've kept things like as integers here, like dollar amounts. We have a little bit of a range, right? So going from 3 to 2, notice when I calculate total revenues, they're the exact same. And that's because I was on the unit elastic portion of the demand curve. As soon as I'm on the inelastic portion, now, if I lower the price, what's happening? I'm selling more units. What's happening to my total revenues? They're going down. Sure enough, as I lower the price, when I'm on the inelastic portion, if I calculate total revenues, what do I notice? They're decreasing. So I'm not making this up, right? Like you can use any linear demand curve and prove this to yourself with numbers that if you are on different portions of the demand curve, inelastic versus elastic, you want to do different things. If I'm on the elastic portion, what do I want to do? To increase total revenues, I want to lower the price. If I'm on the inelastic portion, what do I actually want to do to increase total revenues? Increase the price. Or said differently, no matter where I'm at, I want to move towards the unit elastic point if I'm trying to maximize total revenues, right? In either scenario, no matter where I'm at, I want to increase or decrease the price so that I'm moving towards that unit elastic point because I know that's going to increase my total revenues, okay? Any questions on that idea before we keep moving here? Also, if it wasn't clear, how was I coming up with these elasticity measures? I was simply taking that percent change in quantity over the percentage change in price, okay? Any other questions before we keep moving here? So we already looked through these, right? These are the elastic portions. As I lowered the price, I was increasing total revenues. Inelastic portion, lowering the price would decrease the total revenues. Unit elastic, no change, right? We're at that maximum point. So I've got this. I probably won't get to this today. I might start Tuesday's class with it. And we kind of already talked about this, but I'll show you in a slightly different way, right? So the reason why elasticity measures is because if I'm focusing on what's happening to my total revenues as a company, when I lower the price, I'm making less per unit that I'm selling. That's a bad thing. But by lowering the price, I am now selling more units, right? So what I really care about is that relationship of, am I making more by the number of additional units I'm selling than what I'm losing on each unit I was selling before? So the way we can kind of think about this is, let's say I started out and I was selling, I charged a price of $4. Given the current demand, I'm selling 1 unit. So what's my total revenue? If I'm selling 1 unit for $4, my total revenue is $4. If I lowered the price to 3, I can now convince this consumer to buy 2 of this drink, right? So they're now buying 2 at a price of 3. What's my total revenue? 6, right? So my total revenues have went up by lowering the price. So by lowering the price, I know that's a bad thing for total revenues. So how is total revenue going up? Because people are very responsive to that price change and buying a much larger percent of units. So it's still a 1 unit increase, but it's a large percentage increase in the number of units I'm selling. So notice when I go from $4 to $3, yeah, I'll lose $1 on that unit I was selling before, but I'm going to gain an additional $3 by selling this second unit. So what's happening to total revenues? It's going to go up by $2. Sure enough, we said it went from 4 to 6. Now, if I'm at the unit elastic point, what should be true when I change the price? My total revenue should stay the same. Unit elastic, it's a very small portion, but changes in the price and that total revenues stay the same. So here, if I lower the price from 3 to 2, I've only convinced the consumer to buy one more unit. So I've lost $2 on the previous 2 units I was selling at the higher price. At this new lower price of 2, though, I've sold an additional unit, made an additional $2. I lost 2 on the first units, made it. What happened to total revenues? Remain exactly the same, right? And I could do that, right? $3 times 2 units is 6. $2 times 3 unit is 6. My total revenues haven't changed. And here it's the same numbers, so it's really easy to see this. Going from 3 to 2, 2 to 3, when we use the midpoint method, that's the exact same percentage change. My elasticity would be equal to 1. Now, if I keep going past that unit elastic point, I'm now on the inelastic portion. Now I know when I change the price, people are going to be pretty unresponsive. So now if I lower the price, that's going to hurt my total revenues. But if people are unresponsive, they might keep buying about the same amount. So I don't really get a gain from selling that many more units. So here, if I go from $2 to $1, I'm going to lose $1 on each of those previous 3 units I was selling, but I convinced the consumer to buy a 4th unit, but I'm only charging $1 now. So what's happening to my total revenues from this price decrease? They're actually going to go down by 2, right? So here when I'm on the inelastic portion, if I keep lowering the price, now I'm actually decreasing my total revenues, okay? So just a different way visually of kind of seeing what I had kind of drawn out with those stacked graphs, okay? Any questions on that before we keep moving here? Okay, so I already drew this out for us. We'll switch gears a little bit. We'll kind of revisit this in the in-class quiz here I've got in a little bit. But we're going to talk now about a couple other types of elasticities, okay? So the first one we're going to talk about is this cross-price elasticity. So up to this point, we've only talked about the price elasticity of demand. So the cross-price elasticity of demand, or just sometimes referred to as the cross-price elasticity, is how responsive is the quantity demanded of good X going to be when the good of some, or sorry, when the price of some other good Y changes, right? So what does this sound like? And this might be a good point to mention. I'm assuming all of you have watched those replacement videos I posted last week for Module 3. What does this sound like for Module 3? If I've got 2 different goods, they can either be substitutes or complements, right? So this cross-price elasticity is going to tell me something about, are these goods substitutes or complements for the consumer, okay? So I didn't want to do that. I wanted to do this. There we go. So when I'm thinking about this cross-price elasticity, I kind of gave you this less technical way of remembering this last class, and we'll kind of see it here a little bit today. I said, anytime we're calculating elasticity, so we usually write cross-price elasticities as kind of X and Y. We're looking at 2 different goods. And it's going to be, how does that second word, that's what's in our numerator, so the percentage change in the quantity demanded of good X, right? That's what's going to go in our numerator. So it's kind of like the price elasticity of demand in that we're still looking at how responsive are consumers and how much they're buying of good X. But we're now looking at what are they responding to? A cross price change. So it's now how are they responding to a price change in another good? Not the same good, but some other good, okay? So I'll start out with, I think was probably the easier one first. Let's say I've got a positive change or an increase in the price of good Y. as a result, and you can think about this maybe if you're looking at cross prices, think about if you have both goods in the store. If good Y becomes more expensive, and as a result, people buy more of good X, what would that make those two goods? Substitutes, right? If one of these is becoming more expensive, and as a result, people start buying more of another product, they buy less of Y, more of X, they must be substituting between the two. Or think about this differently. If the price of Y goes down, and as a result, people buy less of good X, that must mean that as Y is becoming cheaper, people are substituting towards buying that, not buying good X. So anytime you have these change in the same direction, positive over a positive or negative over a negative, what is our cross price elasticity going to be? Greater than 0, right? This is going to tell us that these are substitute goods, okay? Now, if I have the price of good Y go up, and as a result, people actually buy less of good X, what must that mean? Well, if Y is becoming more expensive, and I stop buying good X as a result, it must mean that I'm using these two products together. So always anchor the idea of complements with something that makes sense to you. So like people will use like peanut butter jelly as an example, or what are these? The one that to me is always universal is batteries and anything that requires batteries. If, in fact, electric vehicles, for a second, the price of lithium was really high and lithium batteries like doubled in price. What do you think happened to electric vehicle sales? They went down because I can't drive my electric vehicle if I don't have, an electric lithium battery to power it. So anytime these two things move in opposite directions, negative over a positive or positive over a negative, my cross price elasticity would be negative, which would tell me that these two goods are complements. So this cross price elasticity, the sign of it tells me whether or not, we don't just have to guess if goods are substitutes or complements. We can actually look at data, calculate it, and determine whether or not, based off the cross price elasticity, if it's negative, they're complements on average. If it's positive, they're substitutes. Okay? Any questions on this idea? And everything we've talked about with elasticity still applies. Like, what if this was like positive 0.1? Well, they're still substitutes, but this relationship would be pretty what? It's close to 0, so inelastic. What that's telling me, if it's inelastic between two goods, that means that yes, they're substitutes, but they're like weak substitutes, right? That when the price of Y changes, the price of this other good X, or sorry, the quantity of this other good X, it doesn't change by a whole lot. It's not very responsive. Now, if I had something like negative 4.3, tells me they're complements because it's negative, but the fact that it's greater than 1, it's elastic, we would say that the quantity demanded from good X is very responsive to the change in price of good Y. So these would be very strong complements, right? So you can kind of think about being very elastic in terms of cross price. That's telling you that there's a strong relationship. If it's inelastic, whether they're substitutes or complements, that's telling you it's a very weak relationship. What would the weakest relationship possible for either substitutes or complements be? 0, which would mean that two goods are. So if the price of Y changes, people buy the same amount of good X, we would say those two goods are unrelated, right? They have no relationship. Now, do we ever see exactly 0? Probably not, but I mean, there could be something where we see something very, very, very close. Right? All right, so I've got this kind of summarized in the slides here, but I think just walking through it, kind of thinking about the intuition behind why that sign tells us they're complements or substitutes was something kind of worthwhile, okay? Any questions on that? Okay. We'll do this. We'll do, we'll do the quiz first, actually, since we're talking about this stuff right now. And then we'll kind of finish out class with the rest of it. So where are we at in time? So we got 12:25. Okay. Oh, that's not what I wanted. We'll go here. Give us the next 10 minutes. So this should show up under the quizzes tab, or if you go to the home page, kind of under module 4's heading. I'll put up another module heading for next week, which is like the exam materials, and I'll put all the kind of exam files in there after class today. But for right now, now where's my preview option? Oh, because someone already entered this. Okay. How do I do this? There it is. All right. So waiting for my preview button to pop up. Okay. So we've got 2 questions here. We want to think through each one of them. Okay. So the first one is telling me something about, I think, a pack of cigarettes. And we're told kind of where the current price starts, where it's moving to, and we're thinking about what is happening to total revenues as a result of this price change. So we start out at $4. We're moving to a price of $5. On that portion of the demand curve, we're told that the price elasticity of demand is 0.4. If I raise the price from 4 to 5, what's going to happen to my total revenues? Okay. So first of all, which of these should I be able to rule out right away? I mean, maybe I think indeterminate isn't an option, but for sure, what would have to be true if revenues don't change when I change the price? What portion of the demand curve were we on? Unit elastic, in which case my price elasticity of demand would be 1. So I know that doesn't make any sense at all, right? So any problem you have on a quiz or an exam, you probably can draw something out that is going to help lead you to the correct answer, right? You don't have to like memorize all of these different like rules, and a lot of the times drawing these concepts out is going to help lead you to the correct answer. So if I started out with a linear demand curve, and this is where we said what? The unit elastic point is going to be somewhere in the middle here, right? So at that unit elastic point, what was true about total revenues? They were at their highest point or maximized. And then as we move in either direction, the quantity, we saw total revenues were declining. Now, where is the inelastic portion? It's the same visual. This is also where the visuals will help, especially here, because it's very intuitive. If I look at any point above the unit elastic point, my elasticity measure is going to be greater than 1. So at any price above the unit elastic point, I'm going to be on what portion of the demand curve? If the elasticity is greater than 1, the elastic portion. Any price that puts me on the portion of the demand curve below the unit elastic point, I'm going to have an elasticity less than 1, or I'm on the inelastic portion. Okay. Now, I told you the price starts out, and when you move from $4 to $5, that the elasticity was equal to what? 0.4. So I know I'm somewhere down here on the inelastic portion of my demand curve. So by starting out at $4, here's my total revenue. If I increase the price to 5, what's happening to my quantity? It's going down. As my quantity goes down, I'm moving up the total revenue curve. So my total revenues are increasing, right? Now, if I had the same kind of setup, but I told you that this company decided to lower its price, well, what's going to happen there? If I'm lowering the price, I'm increasing quantity, I'd actually be going to lower total revenues, right? So kind of drawing this out, knowing whether or not you're on the elastic or inelastic portion of the demand curve, you can determine what's going to be happening to total revenues from these price changes, okay? So this red one was the kind of lined up with the way that that question phrased it, right? We were increasing price from $4 to $5 on the inelastic portion. Now on a quiz or exam, what could I do? Well, I could change this to you're on the elastic portion and you increase or decrease the price. And you could do kind of a very similar thing. Okay. Any questions on this idea? Okay. Now, the second question told us there was these two goods and the cross price elasticity was equal to, I think, negative 3.2. Right? So I know that my cross price elasticity is the change in the quantity of good X, but I'm now looking at across products. So it's how is that responding to a percentage change in the price of good Y? So if this is negative, I can think about this one of two ways. I know that my numerator and my denominator have to have different signs. So let's think about if Y is becoming cheaper or the price is going down, and as a result, I buy more of good X, what does that mean these two goods are? So Y is becoming cheaper, and as a result, I actually buy more of X. That must mean I'm using these two goods together, or they're complements, right? I can think about if the reverse were true. If it was positive, when Y is becoming cheaper, and that would mean I have to be buying less of X. So if Y is becoming less expensive, and as a result, I buy less of X, that must mean I'm substituting away. So anytime we have a positive cross price elasticity, we said that meant they were substitutes. Positive over a negative, that's going to give us a, oh, sorry. I wrote substitute. If it's greater than 0, they are substitutes. If it's less than 0, that tells us they're complements. Okay. Now, the sign tells us whether or not they're complements. But which of these is larger is the second part of the question. Well, if I have an elasticity that is in absolute terms greater than 1, what would have to be true about this fraction? The numerator has to be larger, right? So if it's in absolute terms greater than 1, I know that my numerator must be greater than my denominator. And I think the way the question was phrased, it actually said the percentage change in price is blank relative to the percent change in the quantity demanded. So it must be that my percentage change in price is less than, right? So the sign tells me about whether or not they're substitutes or complements. The value would tell me about the relative size of the response in good X's demand to that change in the price of good Y. Okay. Any questions on that before we keep moving here? Okay. So kind of that was our first question, right? We kind of talked through, we're on the inelastic portion, increasing our price was increasing our total revenues. And then we said the negative sign told us about whether or not they were substitutes or complements. Being negative, we had complements, and that percentage change in price must be less than, or that denominator was less than our numerator. Okay. Yeah, right. If we're just talking about the percentage change, we're not concerned with the direction. We're just comparing whether or not one is larger in absolute terms than the other, right? Any other questions on those? Yeah. All right. So I think I've got it set to end in a minute here. So before I'll answer your question. This third question, there's no right or wrong answer. Basically, on Tuesday's class, if I had to start picking and choosing questions, which module would you want to see reviewed the most? I'll try to make sure I'm spending more time on those questions. So kind of get that selected, get that kind of some quiz submitted here. I think I've got it set at 12:10. So in the next minute, kind of getting that submitted. But we had, they were complements, and the price change was less than the quantity change. Okay. So the reason why I knew that, oh, hold on. The reason why I know that's true is, I mean, so maybe if I write it out slightly differently. If my cross price elasticity is equal to the change in the quantity demanded for good X over the percentage, percentage change in the price of good Y. If this is equal to negative 3.2, in absolute terms, this is greater than 1. How is a fraction greater than 1? If the numerator is greater than the denominator. So that's how I knew that the percentage change in that quantity demanded for good X has to be greater than the percentage change in the price of good Y. Right? I mean, if this is greater in absolute terms than 1, the only way that's possible is if the numerator of that fraction is greater than the denominator. Yep. So that's how I know about just the relationship directionally of the size of those changes. Is that what you're asking? Okay. Yep. And then if it was less than 1, it would be flip, right? The numerator would have to be smaller. Yep. Okay. All right, so we've got a little bit of time left to get through the rest of our material here today. So we kind of have a similar thing, and I'll set us up here thinking about income elasticities. So once again, not the most technical way of remembering it, but anytime I've got an elasticity, so if I'm looking at instead the income elasticity of demand here, so we use M for income in economics, or whatever. I think I generally is something else, and so that then kind of income becomes M. What we're looking at is the second word is what goes in our numerator. So it's still the percentage change in the quantity demanded, but the denominator is the first word. It's now how responsive is the demand for this product to changes in income. Okay, so instead of a cross price elasticity of demand, it's the income elasticity of demand. So same kind of thing. We would find percent changes the same way using the midpoint method. So what we really care about here, the only real new thing, is that let's say if I saw an increase in income and as a result people buy more of something, we had in module 3 there was 2 types of goods when we talk about income, normal and inferior. So if I have more money and I buy more of it, that makes it a kind of a normal good, most products, right? So anytime I've got this income elasticity that's positive over a positive would be a positive, or if income goes down and I buy less of something, still would give me a positive income elasticity. That's telling me that they're normal goods. If I ever have more money and as a result I buy less of that product, my income elasticity is going to be negative. If I have more money and I buy less of something, that's what we're going to call an inferior product. So this is the idea that as I have more money, I'm more likely to buy used cars, but I'm less likely to buy, if I have more money, I'm more likely to buy new cars, less likely to buy a used car. Used cars are inferior goods, right? Or as I have more money, I might be, less likely to buy, questionable, packaged deli meat from Kroger and go to the actual, guy behind the deli who's actually cutting it fresh, right? So there's going to have some of these inferior products where when I have more money, I buy less of them, making my income elasticity negative, telling me that these are inferior goods. So once again, we don't just have to guess if they're normal or inferior. We can look at the actual data, compute the income elasticity. If it's positive, we would say it's on average a normal good. If it's negative, on average, it's an inferior good. Okay. And then I've kind of got that summarized here. That's nothing, I don't think, too crazy. I won't spend a lot of time on this because really on the quizzes and the exams, I'm not going to focus a lot on this. But it is kind of interesting. It's something that you will see out there, which is even when we're looking at normal goods, we can actually break these down into 2 different categories, which is our necessity and luxury goods. So if we think about it this way, the sign tells us if they're normal or inferior, but we can still look at whether or not they're elastic or inelastic in terms of their response to income changes. So if I have an elasticity that's positive, they're normal goods, but it's in between 0 and 1, that's telling me it's inelastic to income changes, or it's not very responsive to changes in income. So even though I buy more of it when I have more money, I don't really buy that much more. So these are going to be things that no matter how much money you have, you probably need about the same amount. Gasoline, food, the number of shirts you own, it might go up, but it might not go up by a lot. I always like throwing here like toilet paper, right? Like you're going to buy the same amount probably regardless of how much income you have. You might buy a little bit more because maybe now you have an additional bathroom in your house or something like that, but it's going to be about the same. It's not very responsive to income changes. Now, when we get an elasticity that's greater than 1, we're going to call these luxury goods. And generally, the way that we see this is that when I have more income, how do I get a really large percentage change in the quantity demanded? Because remember, that's what's in my numerator, even for my income elasticity. Usually we see really large percent changes when I'm going from like 0 to 1, right? Or 1. So 0 to 1, what's a luxury good? A house. As I have more income, generally at some point I go from buying no houses to 1 house. That's a very large percent change in the number of homes, the quantity. So my numerator is large. And even if I see like a relatively, moderate increase in income, or you could think about maybe a better example. If I've got Rolexes, I could see a 50% increase in my income. If I go then from buying 0 to 1 Rolex watch, well, 0 to 1, the change is 1, the average is 0.5. That's a 200%. So even a 50% change in income, I'm seeing a 200% change in the quantity demanded. So I'm going to have an elasticity greater than 1. These are typically going to be goods that people only buy when they have really large amounts of income, when they have the luxury of purchasing them. And the reason why we end up with that high elasticity is because we're typically going from 0 to 1, which creates this really large percentage change in the quantity demanded or in our numerator. Okay. All right. So is your income elasticity greater than 1? Because being with you is a luxury good. I found this at one point and thought it fit in pretty well here. So you can try it out. Let me know the success rate. But we got one more thing we got to talk about before we get out of here today. Okay. So just like we looked at the price elasticity of demand, every single principle that we talked about, except for its relationship to total revenues, but in terms of like putting it in the range of inelastic or elastic, how we calculate it, is the same thing for supply. Price elasticity of supply, it's going to be now, instead of the percentage change in quantity demanded, it's just the percent change in quantity supplied over the percent. So it's how responsive are producers or suppliers to changes in the price, right? We're just kind of flipping who we're looking at. Now we got to think about, and I've got some questions. This pops up in module 3 a little bit too. Anytime we see this word producers or suppliers, we now have to start thinking about price is actually a good thing. All of us are consumers. Very few of us in this room are probably producers or suppliers or sellers. Maybe you got an Etsy business or I don't know, my brother buys and sells sports cars, right? That's his little like side hustle. But most of us are consumers, right? For the producers, price is a good thing. So remember, when price goes up, what's happening to our supply curve? It's actually increasing. So we now no longer have to worry about the absolute value, because now every time we see an increase in price, we're also going to see an increase in the quantity supplied. So our ranges are the same. 1 unit elastic for supply, greater than 1 elastic, less than 1 inelastic. I won't spend too much time on this, but the attributes of a product that make it more or less elastic for suppliers are really similar to consumers. So if they have more time to make their production decision, right, they can analyze the market, they can go out and find cheaper materials. Do you think they're going to be more or less responsive to price changes? So if I see the price of something go up and I have more time to like change my production process maybe to make that good, well, I can be more responsive to that price change, right? In fact, if I have this huge production facility, I can start to change the types of goods that I'm producing and selling. A lot of these cheaper goods on Amazon, that's all the companies are doing. It's the same company. They're just adjusting their production process to create different trinkets, different types of t-shirts, different prints, right? They have more time to make the decision. They can be really responsive to whatever's popular, whatever can sell for a higher current price, okay? So more time, just like with consumers, we can be more elastic, less time, less elastic. And that really kind of coincides with if my production process is more flexible, I can be more responsive to price changes. So for instance, if I have, something set up where like the only thing that this good is, or they have like these huge CNC machines and they can create like all kinds of, it's basically like a giant 3D printer, and they can make, something for cars, planes, whatever. They're very flexible. They can start making car parts if all of a sudden these parts for your car engines go way up in price, or if all of a sudden, jet engines, I can switch it over to this, right? I can be very, very responsive. So the more flexibility I have, the more elastic we'll see supply be. This also goes, applies to workers, right? If it's really easy for me to hire and fire workers, so this is like, if I'm thinking about like department stores, fast food places, I can hire more workers or get rid of workers depending on if the price of a good goes up or down. I can respond to what the current market is a lot easier if I can hire and fire workers quickly. Now, if I want to respond to markets for like, I don't know, creating rocket ships, it's probably harder for me to find the engineers required. I probably can't just all of a sudden hire 5 more engineers to produce more rocket ships and respond to the fact that they're. So anytime I have more flexibility in my production process, whether that's through my workers, whether that's the raw materials that it requires to make the product, I can be more elastic. So it's not, I don't think that one, I think it's pretty intuitive when it comes to supply. But I had 2 examples I think are interesting to think about. So in terms of suppliers and how we want to kind of change our mindset. So in the 90s, like the Sudanese slave trade was like a big problem. And there's all these groups that have this genius idea. We're going to go in, we're going to buy all the slaves and free them, right? We've got the money in the United States, so like, why not do that? So they went in, they outbid everybody, right? We were buying all these slaves. Well, what was that doing to the price? If they're outbidding them, they're increasing the price. Well, why is that a problem? If suppliers are very elastic for the slave trade in Sudan, when the price went up, what happened to the percent change in the quantity supplied? It went up by a lot, right? So the fact that they're coming in and like they weren't, they weren't just barely overbidding people. They were guaranteeing, they were like trying to buy all these slaves. Well, yes, they bought them and freed them, but what happened? The quantity supplied skyrocketed. They just went out and caught even more, I shouldn't say caught, right? Got even more slaves to then put back on the market. So what did they do? They made the problem worse, right? If they understood anything about, this market, or they tried to look at some actual data to see, was this an elastic market, they would have known this was not going to be the solution that worked, right? So kind of a weird example of applying like market-based principles. And it's weird to think about slavery as that, but really in practice, there were buyers and sellers. This was a market. Unfortunately, this was a market, right? I then also had this example. You can kind of look at the link. It's kind of interesting. They went out and found people that you might see roaming around Bloomington, and they gave them like hypothetical questionnaires. They gave them artificial budgets and said, if you could buy X number of X number of bags of heroin or ounces of coke at these prices, how much would you buy? They collected all this data. They then started to calculate. They had quantities, they had prices. They could calculate cross price elasticities, price elasticities of demand. Guess what the price elasticity of demand for most of these products, these drugs was? Very inelastic. One I picked out of this paper that I thought was particularly interesting to me was the cross price elasticity of heroin and cocaine was found to be negative. So what does that mean? That means when the price of heroin went up, people actually bought less cocaine. So that means these 2 goods were, it's a negative cross price, complements. So I don't know, the story is, get out of my heroin days, I need cocaine to pick me back up. I don't know, right? I'm not a user of these products. So, but it is interesting. This is actual data. You can dive into, it's a published article. So I'm just trying to show you what we talk about in class can be applied to kind of these non-traditional markets. Other than that, quiz 4, due at the end of the day Monday. No module reading this week because the exam is next week. Have a fun, safe weekend, and I will see you guys on Tuesday. I will also be back in my office hours physically next week.